Slides are moving.
Yes,
Hello.
sir. Yes, sir.
Okay.
Yes, sir. Yes, sir.
Shall we start?
Yes, sir.
Yes, sir.
Okay. Hmm. Uh, Basically, today we discuss about your Lagrangian formulation and particularly first 2 or 3 units of the Lagrangian formulation that is in your course. First, we quickly go through over the theory parts, and if you have any doubt, then I will ask questions. I think I will take 45 minutes a class, then 15 minutes discussion and doubt clearing. Okay. Oh,
Sir, namaskar. This is
Namaskar,
Dr.
sir.
Panigre.
Namaskar, sir.
I request to all the students, don't disturb in between the class, and whatever the technical issues are there or whatever regarding IGNO problem, you can write to us. Just you allow to the teacher to, they will taught you upon whatever you require for us. You just ask us, or last 5 minutes you can ask your question to teacher. For the each paper, if there is a 4 credit, we are going to give you 4 class. Fine. We MPH-2 and MPH-3. There is only 2 class, and other than that, all papers are 4 class. It's a distanciation system. You have to bear with us. Go ahead, sir.
Okay, thank you. Okay. For mechanics of particle, as you all know, if r with the radius vector, then v its derivative is velocity and its double derivative is acceleration. And linear momentum, another physical quantity, you know that it is a product of mass and velocity. So actually, linear momentum contains the motion, or you can say motion contained in the body is known as linear momentum. But according to Newton's second law of motion, the rate of change of momentum is equal to force. So if force will be zero, then P will be constant. dP by dt is zero, so derivative of a constant is zero, so P become a constant. So in what we can say that if the total force acting on the particle is zero, then its linear momentum is a conserved quantity, which is your conservation of linear momentum. Similarly, you know, angular momentum is related with linear momentum as L is equal to R cross P. And the moment of force, which is called torque, it is R cross F. So if you put in place of F dP by dt, then it will become R cross dP by dt. But R cross dP by dt, you can write the derivative of R cross P minus dr by dt cross P, because derivative of u plus b is derivative of u or derivative of b. Similarly, with cross product, the two terms here, derivative of a cross b is equal to derivative of a cross b plus a cross derivative of b. Okay. So, but dr by dt is velocity and p is mass into velocity, v cross v, and you know v cross v cross product of same vector is 0. So it only becomes d by dt of r cross p, or r cross, since r cross p is equal to L, dl by dt. So if you put torque is equal to 0, then L becomes a constant. Okay. Okay. This is the conservation law of angular momentum. Okay. Then we next go for third one, conservation of energy. For conservation of energy, you know the basic principle of work done. Work, the amount of work done from taking a body from point 1 to 2 is the integration of F dot ds, force in displacement. Okay. But if you see force in displacement, force is equal to mass into acceleration. Okay. But acceleration is equal to dv by dt. Okay. So it becomes mass into dv by dt. Again, ds, displacement, you know velocity is equal to ds by dt. So ds is equal to v dt. So in place of ds, you can write v dt, v into dt. Okay. So if take m out, then it will be dv by dt dot v dt, which can be written as d by dt of v square. If you take d by dt of v square, it will be 2v dot dv by dt. So 2 and half cancel. So this term can be written as half into d by dt of v square. What I write here. So if you see integrating this, it becomes v square limit 1 to 2. So v2 square minus v1 square. But you know half mv square is a kinetic energy. So this will be half mv2 square minus half mv1 square. Kinetic energy at point 2 minus kinetic energy at point 1. Okay. So work done is equal to change in kinetic energy, which is as work energy theorem. Well, change in kinetic energy is equal to amount of work done. But if you assume that force is a conservative force, then we can say the work done by this will be 0. The work done by a conservative force in a closed path will be 0, because if a force is conservative, then work done is path independent. Path independent means suppose you go from A to B. So whatever work done from going A to B, in what way? Let's say it is one way. If you go to B to A, another way to work done will be same. So here what positive and a total amount of work done, it becomes 0 if you add those two. So work done over a closed path will become 0 for a conservative force. But conservative from this equation, you can using your Stokes theorem, and this term force and vector identity also, you can know the gradient of del V. If you take F as a gradient of a scalar potential, then ds will be 0 by using the theorems of the vector theorems, by like Gauss divergence and Stokes theorem. You can easily prove that this is a negative gradient of potential. Okay. So if we take the work done, negative gradient of potential, the ds, then it will be obviously f dot ds becomes minus dv, because del is del by del r. So del by del r v into dv, it becomes dv. So integrating, we get v1 minus v2. So if it's a conservative force, then its work done will equal to change in potential energy. But from work energy theorem, we know that work done is equal to change of kinetic energy. So if we equate both two, you found that T1 plus V1 is equal to T2 plus V2. Which is the energy conservation theorem of a particle. If the force acting on a particle are conservative, it's the important point. If the force is conservative, then only when total energy conserved quantity. If force is not conservative, then energy cannot be conserved. So conservative force or conservative system means the energy is a conserved quantity. Okay. Then goes to the mechanics of a system of particle. Those three conservation what we already discussed, they are for a single particle. If there are a large number of particles in a system, how we can derive the conservation laws? Basically here come the interaction between two particles. The extra factor which comes the interaction between two particles. When we consider a single particle, the only force acting on it is the particle, single particle. But if there is a system of particles, then the force on one particle is due to force on two particles, three particles, four particles. So that is the extra force, which is known as the internal force. That is, I will write FGI. FGI is the internal forces, force on the jth particle due to ith particle. Okay. The force. So extra force is an internal force. So for these conservation laws, we have to assume that that the internal forces are obeys the Newton's laws of action and reaction. They are also conservative. And action and reaction, Newton's law means Newton's third law, you know that Fij is equal to minus of Fji, which is Newton's law. So here we assume that internal forces are obeys the Newton's third law or action of reaction. or f ij is equal to minus f ji. Okay. So if you use this term, we can easily derive this. Again, another concept we use, if it is number of particles, then we use a term center of mass. Center of mass means we assume a point, the whole force is acting on that point. Or you can say for a regular body, center of mass is equal to center of gravity, and you already know the center of gravity is the balancing point of the system. And suppose there is a pen or stone, you can put it on a point by finger, it will be balanced. That point is your center of gravity or center of mass. For regular body, center of gravity is equal to center of mass. So center of mass means we assume the whole force of the system is acting on that point of the system. The whole force is acting on that point of system, which point is called center of mass. And by definition of center of mass, the position vector of center of mass is equal to sum of product of mi/ri, mass of I particle and radius of I particle, sum over I. Means product of all mr, m1 r1 plus m2 r2 plus m3 r3 all divided by whole mass of the system. It is summed over mi. The center of mass, and so if you calculate by the center of mass for m, d square r by dt square is equal to the external force. So if external force becomes 0, then what happens? We can check that m d square r by dt square is equal to 0. Okay. But we know momentum p is equal to mass into velocity m into dr by dt. So for a system, it will be sum of mass into velocity of each particles, m1 v1, m plus m2 v2 plus m3 v3, and mi dri by dt, or actually that is m dr by dt. So if take its derivative, then m is a mass constant, so it will be m d square by dt square, which you found m d square by dt square. So if f is equal to 0, m d square by dt 0 means dp by dt is equal to 0. So p is a conserved quantity. That is the conservation of linear momentum for a system of particle. Similarly, using like previous single particle case, what you use L is equal to R cross P, tau is equal to R cross F. Here you can also prove that for a system of particles, that L dot or dl by dt is equal to total torque acting on the system. Okay. And so if torque is equal to 0, then L is a constant quantity. That is the conservation one. Then third thing, the conservation of energy, like single particle case, here we only extend that for a number of particles. What similar work done will be total work done, sum over work done on each particle. Okay, sum on the internal force and external forces, and assuming that internal forces obeys Newton's third law, Fji is equal to minus of Fij, and adding this you can easily get, and using the concept of single particle case, you can prove that W1 is the Work-Energy theorem, W1 to T2 minus T1, and similarly you can prove that change in potential energy, W1 to equal to. So if you combine these two, then you say that total energy of the system is conserved. Okay, that's only mathematical derivations. You can check it. Okay. Then we go to the second part, actually important constraint. So we are going to that slide. Constraint and generalized coordinate. Okay. So constraint. What do you mean by constraint? Literally, constraint means limitations or restrictions. Restriction on the motion. Constraint limit the motion of the system. For example, a bird can fly, and it can go to up or move on the land. It have a move left, right, everywhere. It has you can go anywhere in the space. So if you say it has 3 degrees of freedom, you can go to if you in terms of our axis, x-axis, y-axis, z-axis means it can fly. But a human being, we can fly. So in that sense, we can say we have a constant that we can fly. We can move on the land. We cannot go up. Okay, that is the constraint. So due to this constraint, our degree of freedom decreases. Okay, for a degree of freedom means the number of coordinates which can vary independently is called the number of degree of freedom. So when we are moving, I think we can say on a plane, so we need two coordinates to locate us. But when bird is flying, you need three coordinates to locate him. Okay. So constant actually limit the motion and decreases the degree of freedom. Due to constant degree of freedom, the system decreases. For a pendulum, when a pendulum is moving, here is constant is the length of the rod or length of the thread is fixed. So only a angle is changing. So constant reduces its degrees of freedom. Okay. Constants may be classified in various ways as the holonomic constant. Holonomic constant means if the condition of constant can be expressed as an equation connecting the coordinates of the particles and time only. It does not contain velocity. It's called equation of constant, means a constant can contain position or velocity v or r dot we write and t. A constant equation can contain position coordinate, velocity coordinate and time. But if the constant coordinate only contain position coordinates and time, and there must be equality, it is equal something, equal sign, then we call a holonomic constant. If there is inequality, we can say holonomic constant. That is non-holonomic. If there is a equality, it is equal to something. So function of if rt position coordinates and t is equal to 0, then we call it holonomic constant. But if it contains f rt less than 0 or less than equal to 0, greater than equal to 0, it will not be holonomic. Okay. So for example, a simple pendulum what we discussed, here the constant is length of the rod is fixed L. So you can write r minus L 0 in terms of function r minus L 0. So it's equality symbol and it only depends on position coordinate. L is a constant, so it is a holonomic constant. Similarly, the rigid body, rigid body, the distance between any two points is fixed. So if you take distance mod square, it will be fixed. Ch square for any particle. So a constant can be written like this. So it's equality sign. So it is a holonomic constant. Similarly, particle constant to move along the curve or on a given surface, it is a holonomic constant. Second one is non-holonomic constant. If the conditions of the constant cannot be expressed in the form as equation 1, if we cannot write like the a function of rt is equal to 0, then it is a non-holonomic. Two cases, either it is a not equal sign,
Not
second
equal
thing,
to
it velocity. Hello? Any problem?
No, sir. No, sir.
Okay. It's called non-holonomic constants. For example, the motion of a particle placed on the surface of a sphere in a gravitational field. When it is moving in the gravitational field, it may, when it is here, it may fall. So here the position is greater than A. If the radius J is greater than A, it's not fixed. It may follow this path. If it can't, it will follow the path on the sphere. It can move. It is equal to A. But when a particle, it can fall due to gravity. So this is a constant. Here inequality sign. Due to inequality sign, this is a non-holonomic constant. Here constant is on position coordinate. But here inequality sign. Due to inequality sign, it is a non-holonomic constant. Another example
Sir,
is the most.
hello.
Yes. Yes, sir.
Sir, for a rigid body, what should be the constant and what should be its degrees of freedom? Please explain.
Okay, degrees of freedom means for a rigid body, actually constant is the distance between any two points is fixed. Okay.
Okay.
Suppose when consider in space we need three coordinates to define a particle. Also, it has three
Okay.
degrees
So,
of freedom.
three, so three degrees of freedom.
Let's say for a rigid body, we construct a rigid body. We take first particle, let's say one particle. So we need three coordinates. Then I bring the particle number 2. It needs three coordinates. But according to the definition, the distance between two is fixed. We know the
Hmm.
distance of 2 from 1. So only extra two coordinate is needed to define its position. So 3 plus 2, when a third body we take, it needs 3 coordinates. But we know the distance from 1 to 3 is fixed, 2 to 3 is fixed. So only extra 1 coordinate is required. When we take fourth one, it needs it requires three coordinates. But we know that due to rigid body, the distance from one, distance from two, and distance from three is fixed. So no extra coordinate is added if you add fourth body. Similarly for fifth, sixth, no extra coordinate is required. So degree of freedom of a rigid body is 3 plus 2 plus 1 is 6 in 3 dimensions. Generally we call it 3 dimension space. But if you go for a dimension, higher dimension, is some question and ask in D dimension, what happened? So you follow here 3 dimensions. If D dimension for particle 1, you have to need D coordinates. If particle 2, we need D, but 1 constant, distance between 1 and 2 fixed. So we need D minus 1. Similarly, plus D minus 2.
I think day factorial.
Up to 1 is equal to how much? A summation. It is equal to n into n
सर
plus 2 or
हेलो
d into d.
हाँ सर सर जब
Yes,
हम
sir.
लोगों ने ये पढ़ा था
हाँ,
हाँ हेलो
हेलो बोलिए. हाँ हाँ
में वो डिग्रीज ऑफ फ्रीडम पढ़ा तो थर्मोडायनामिक्स में
हाँ
वो जो मॉलिक्यूल था उसका ग्रेविटेशनल मोशन
हाँ, वो तो मॉलिक्यूल में 3 डाई एटॉमिक होगा तो
उस तरह
डाई
हम
एटॉमिक
लोगों ने
होगा.
डिग्रीज ऑफ फ्रीडम कैलकुलेट किया तो यहाँ
हाँ
पे समझ लीजिए आपका पास जो पेन है जो पेन एक रिजिड बॉडी है तो उसका डिग्रीज ऑफ फ्रीडम में कैसे
I'm calculating. I am calculating this now for a rigid body. Degree of freedom is 6. Same way you are calculating. For
ओके
a monoatomic molecule, you have to 3. But when a diatomic molecule, di means 2 molecules are there. For first one is 3, second needs 3. But there is a constant, the distance between two is fixed. They are connected. So it will be
ओके ओके
2.
ओके
3
सर
plus 2 equal to
सर
5.
समझ गए सर और एक हाँ इसमें जो कॉन्फ्यूजन आ रहा है जो इसमें ट्रांसलेशन कितना हो रहा है कितना रोटेशनल हो रहा है और कितना
Oh,
वाइब्रेशन
वो
हो रहा
heat
है और
translation
सिक्स
तो
में से
वो thermodynamics से हम बात करेंगे. Okay. Here all are we are mechanical system we are discussing. Okay.
ओके 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 सर हाँ
Okay.
कंटिन्यू नेक्स्ट
Okay.
कंटिन्यू ओके
Then another kind of constants are there time dependent constants. A time dependent constant actually depending on time we can divide in two parts scleronomos and rheonomos. If the condition of constant don't depend on time explicitly, if it is independent of time, then we call it a scleronomos system. For example, simple pendulum, rigid body, you see there is no time term in the constant equation. For a simple pendulum, r minus L0. For a rigid body, ri minus rj square minus a square 0. But for Riemann constant, if the equation of constant contain the time explicitly, then we call it Riemann constant. Okay. For example, pendulum with variable length, bead sliding on a moving wire, and expanding or contracting of spherical container. So pendulum is length is changing, so it depends on time. If suppose container is moving with time, then expanding or contracting of spherical time. So equation of constant contain time. So we call it Riemann constant. Okay. Now, constant introduces two types of difficulties to a solution of the mechanical problem. First difficulty is the coordinates are no longer independent because we see constant means relation when we are the second particle we have two only coordinates for a rigid body, third one because they are related. Coordinates are related. So if coordinates are related, we cannot suppose we have an equation F is equal to dp by dt. Okay. If I take sum of, I write that it contains n number of particles, I is equal to 1 to n, fi, so it will be sum of I dpi by dt. Clear? What do I write? If all particles are independent, 1, 2, 3 are all independent, then we can say each one satisfies the equation f1 is equal to dp1 by dt, f2 is equal to dt by dt. Okay, because f minus this is equal to 0. Okay, but if particles are related, then we cannot say they all particles satisfy the same equation. Okay. That is the first problem. The coordinates are no longer independent, so we cannot say that the equation what the system is satisfying is individual particle is satisfying. If they're independent, we say one is independent of two, so one satisfies the equation, two satisfies the equation, three satisfies here. Suppose what we tell about the force is equal to dp by dt. Another it is easy to understand. So if we take the coordinates, suppose force has x coordinate, y coordinate, z coordinate, and momentum has x coordinate, y coordinate, z coordinate. Since the coordinate x, y, z are independent, so we can from this equation say if the total for this fx is equal to dpx by dt, fy is equal to dpy by dt, and fz is equal to dpz by dt. Then since x, y, z are independent. If they are dependent coordinates, then we cannot say that. Okay. A second problem is the force of constant are unknown throughout the problem. Suppose we don't know what the force of constant for a pendulum or for a gas container. This problem, the force is unknown throughout the problem. Okay. So in other words, imposing constant on the system is simply another method of stating that there are forces present in the problem that cannot be specified directly but are known rather in terms of the effect of the motion. Okay. So we cannot directly see the force, but we can feel its effect. Someone is constraining to move the particle inside the gas container, not go to outside it. But we don't know that force. So in the case of holonomic constant, what we already know, the first difficulty, that is this one, the coordinates are no more independent, it will be solved by introduction of generalized coordinate. The generalized coordinate is only applicable to a holonomic system having holonomic constant. Suppose a system of n particle free from constant has 3n independent coordinates or degree of freedom. If an n particle system there is no constant, that means each particle is independent. Independent means each have three coordinates. So there are
सर वो जो लास्ट लाइन आपने बताया वो थोड़ा रिपीट कर दीजिए मतलब होलोनोमिक कांस्टेंट के लिए ओनली वो जो जनरलाइज कोऑर्डिनेट है वो एप्लीकेबल होगा
yeah. For holonomic
और सेरोनोमिक वो जो
no, what
अदर्स के
type
जो
dependent.
कांस्टेंट
No, so depend we are holonomic or non-holonomic. A holonomic constant may be scleronomic, may be rheonomic. That is depend on time.
डिपेंडेंट ऑफ टाइम
Time is second. When I define a holonomic, it is a function of R and T. It may contain or
Okay.
may not contain T. Okay, depending
Okay.
on the may contain or scleronomos. But
एक्सप्लिसिट ऑफ टाइम और नॉट
yeah. But
और
non-holonomic system we
जनरलाइज
cannot.
कोऑर्डिनेट किसी भी केस में तो जनरलाइज कोऑर्डिनेट होगा ना सो सिर पे पेंडुलम कांस्टेंट मतलब वो होलोनोमिक कांस्टेंट हो वो सेरोनोमिक कांस्टेंट हो वहां पे हम लोग जनरलाइज कोऑर्डिनेट कैलकुलेट कर सकते हैं
No. Depending on time, we divide into two parts: scleronomic, rheonomics. That's different. But holonomic, non-holonomic is different. It depends on the position of velocity or equality, depending on holonomic and non-holonomic. A holonomic system may be scleronomic or rheonomic. A non-holonomic system may be scleronomic or rheonomic. Okay. Holonomic and non-holonomic is important. It is only dependent on time. A generalist cone, if it is non-holonomic scleronomic, then you cannot apply generalized. If it is non-holonomic rheonomic, we cannot apply generalized. We apply for holonomic constant, it may be rheonomic or scleronomic. Rheonomic, scleronomic depending on the time. Here,
ओके 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 मतलब यहाँ पे जनरलाइज कोऑर्डिनेट को डिग्रीज ऑफ फ्रीडम की तरह बिहेव फिजिकली नहीं कर रहा है बट साउंड सिंपल लगता है क्या उसमें वो
नहीं,
जो इंडिपेंडेंट कोऑर्डिनेट होगा
generalized
इसमें
coordinate
वो
is equal to degree of freedom. For any system,
डिग्रीज
generalized coordinate is equal to degree of freedom. Like your diatomic molecule, your generalized coordinate is 5 and degree of freedom is 5.
सो
Those six, instead of
बेसिक
6, it is 5.
बेसिक जो डिफरेंस है इसमें टाइम डिपेंडेंट और डिग्रीज ऑफ फ्रीडम में हम लोग टाइम डिपेंडेंट और इंडिपेंडेंट के बाद नहीं करता बट यहाँ
नहीं,
पे टाइम डिपेंडेंट और डिपेंडेंट के बाद आ रहा है
हाँ,
यही है ना
हाँ,
बेसिक जो डिफरेंस है वो जो
नहीं,
डिग्रीज ऑफ
degree of
फ्रीडम
freedom
और
में
यहाँ पे
time is अलग से degree
जनरलाइज
of freedom.
कोऑर्डिनेट का
Yes. Okay. So if
ठीक
there
है
are k constraints, so we are our degree of freedom will be 3n minus k. Actually, it should be 3n. Like diatomic molecule, it should be 6. Since one constant is present, it will 6 minus 1, 5 degree of freedom. Okay. So generalized coordinate actually 3n minus k number of generalized coordinate. We generally use the symbol q, q1, q2, 3n minus k. All are requested to mute. Please mute. When you have any doubt, you can only ask questions. Hello, someone is on mute. Please mute. Okay, with this. Sushant Kumar Sahu,
अरे
please
भाई थोड़ा
mute yourself.
साउंड तो म्यूट करो.
Okay. So generalized coordinates are the set of independent coordinates which are required to completely specify the configuration of any system without constraint. If there is no constraint, or in case of constant motion, the configuration should be bounded by holonomic constraint. It cannot solve a non-holonomic constant problem. Okay. There are 3n minus k number of generalized coordinate. We use symbol qj for generalized coordinate. Usually generalized coordinate, unlike the Cartesian coordinate, will not form a group of three. You know, each Cartesian coordinate x, y, z form a vector. But here for generalized coordinate, it cannot in general, if it is Cartesian only follow this rule, but otherwise it cannot follow the group of three. Maybe a polar coordinate, maybe a spherical polar coordinate. Okay, maybe a single theta, maybe a singular. Oh. Generalized coordinate may be a position coordinate, may be theta here angle, may be a angle, maybe some other quantity, maybe energy, angular momentum. So general coordinate is not always position coordinate. General coordinate may have any dimension, maybe angle, maybe some dimension of energy, angular momentum, etc. So in case of pendulum, general coordinate is angle. What do we see? In the problem of particle moving a central force problem, there is no constant involved, but polar coordinates are preferred to study its dynamic rather than Cartesian coordinate. Whereas in the motion without constant, sometimes we use non-Cartesian coordinate. In an example of a central force problem, we use polar coordinates. So in general sense, you can say generalized coordinate means coordinate different from Cartesian coordinates. It includes Cartesian coordinates, polar coordinates, spherical polar coordinates, cylindrical, everything. So comes under generalized coordinate. Okay. Then we go for D'Alembert's principle. D'Alembert's principle. Okay, we already discussed constant to problem. हाँ हाँ
सर आपने जो बताया जेनरलाइज कार्टेशियन कोऑर्डिनेट का जो तो हमारा एक्स वाई जेड और टाइम जो थे तीन जो ये जो चार जो कोऑर्डिनेट है ये चार कोऑर्डिनेट कभी भी जेनरलाइज कोऑर्डिनेट नहीं हो सकता क्या?
यही सब
वो किसी
रह सकता है included. Generalized means it contains Cartesian, polar, spherical polar, everything.
एवरीथिंग, हाँ हाँ से वो तो मुझे ये आया. आप समझ लीजिए किसी भी एक पॉइंट को हम किसी कार्टेशियन पे एक्स वाई जेड के उस पॉइंट का पोजीशन डिनोट करता है.
हाँ
तो उसी पॉइंट का जनरलाइज कोऑर्डिनेट कैलकुलेट करेंगे तो उसका जनरलाइज कोऑर्डिनेट क्या होगा? किसी थ्री
ना
डायमेंशन के एक पॉइंट का आपका एक पॉइंट के हम एक्स वाई जेड
पॉइंट एक्स
कोऑर्डिनेट
वाई
से
जेड
डिनोट करते हैं. हाँ तो
एक्स वाई
उसका
जेड
पोजीशन वेक्टर, हाँ 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 सर. लेकिन
polar coordinate
जनरलाइज
r theta,
कोऑर्डिनेट
spherical polar r theta phi you can also use. XYZ in place of XYZ, you can use r theta phi.
तो
Okay.
उसका जनरलाइज कोऑर्डिनेट क्या हुआ?
Generalized coordinate depending on problem, we try to solve it using this generalized coordinate. If a spherical symmetry problem, instead of XYZ, you cannot get any solution using XYZ. We use r theta phi. Okay.
ओके.
Many problems we cannot solve using Cartesian
Like
coordinate.
pendulum, like simple pendulum, theta is the generalized
Theta is the
coordinate.
generalized coordinate. Okay. For non-holonomic constants, please mute. Someone is on. Hello? Ramakrishna Panda, please mute. Okay. For non-holonomic constraints, in some cases we can solve it by using a method of Lagrange's multiplier. Using method of Lagrange's multiplier. Some people are using this. Okay. Okay. So now for the second problem, the force of constant is unknown throughout the problem. To solve this, actually, a method was developed by D'Alembert, which is known as D'Alembert's principle. Okay, we would like to go to that case. Okay. There is a term called virtual displacement. Virtual displacement means it's not real displacement. Real displacement means system is moving in space. We call real displacement. But in some cases, uh, due to its internal system contains number of particles, but the force of constant is acting on them, other forces are acting on them. There is a internal displacement which is called virtual, not real. Real means moving space. Virtual displacement, and that virtual displacement means maybe some position of my coordinate is slightly changing with a little delta ri. Okay, if ri in terms of the function of generalized coordinate, we can write delta ri as like this. We know if a function of xyz, then derivative will be del f by del x into dx, del f by del y into dy, del f by del z into dz. In similar way, if it is a function of this, we can like it derivative this, and this is called virtual displacement. Is a virtual displacement is measured at a particular instant of time, but system moves with time. So we call it actual displacement, but a particular time due to the force of constant, there may be some kind of displacement of a position of a particle. We call it a virtual displacement. Okay. By using this, we use actually D'Alembert's principle. Then another thing is virtual work. Work done due to virtual displacement is called virtual work. Virtual delta, right? The work done due to virtual displacement is called virtual work. And another thing, workless constant we call if the force of constant does not do any virtual work. We call it workless constant. Actually, if we can do this, then our problem constant force of constant removed from our equation. If we set like this, and this setting was first done by D'Alembert. He used this. He developed a mechanism which is known as the D'Alembert's principle to remove this force of constant from the equation of motion. Okay. Generally, our force on the ith particle is applied force for force of constant. If work done due to force of constant becomes zero, then only Fi will be Fi if work done will be Fi dot dri, actual displacement. Okay, this principle of virtual work actually according to principle of virtual work done by the force of constant is zero. So if you put work done by force of constant is zero, so obviously rest force at equilibrium total work done is zero. So condition for equilibrium is total work done is zero. So if work done due to force of constant is zero, rest one is work done by force of applied force must be zero. Okay. Because we know that if system is at equilibrium, Fi is equal to 0. So Fi delta is 0. From that we can conclude this, which is known as principle of virtual work. But it is an equilibrium system. D'Alembert applied to a dynamic system. If system is moving. For a moving system, what is the force? We know for equilibrium, total force is 0. For a moving system, force is equal to rate of change of momentum. So we can make right hand side 0 if I write Fi minus dpi by dt, it will be 0. Okay, and this force on D'Alembert assume these two terms as a force. So obviously what done will 0. Okay. Now we see the D'Alembert use Fi pi dot when dpi by dt is equal to 0 from Newton's law. This so. And taking as a product with delta right, it will become 0. But Fi contains Fia plus Fic. Force of constant, if it is a workless constant, then work done by force of constant is 0. So we have only Fia minus Pi dot delta I is equal to 0. This is known as D'Alembert's principle. A simple thing, not only force minus dpi by dt over 0. But here we exclude force of constant. It is known as D'Alembert's principle. And he proved that there is no force of constant in equation. Okay, he already removed the force of constant. Why it is useful? Okay. The next thing is your Lagrange's equation. We can derive it from D'Alembert's principle. This is your D'Alembert's principle. Fi minus pi dot delta I is 0. Okay. But in place of delta Ri, if you put the expression what we already known, using this expression, uh, we can out the mathematical formulation only.
Sir, hello, sir.
Ah,
Sir, basically, the purpose of the D'Alembert principle is that to determine equation motion of a particle for any system. यही है ना?
no,
तो
to remove the
हम लोग
force of constant from the equation. D'Alembert principle aim is to remove force of constant from the equation. So it will be as a normal equation. If there is no
normal
force
equation.
of
So, before we derive the equation motion from Newton's second law. So, what is the advantage of D'Alembert principle over the Newton's second law?
no, using Newton's second law, D'Alembert developed the mechanism. He removed the force of constant from the equation. And why it is important? From this equation, actually Lagrange's equation of motion was derived. He gave the way or show the way for derivation of Lagrange's equation. So why it is important? In Newton mechanics, there is no Lagrangian
Oh,
formulation.
basically, D'Alembert principle it helps to develop Lagrangian equation.
Yes. It is the important one. But it's just a simple thing, nothing extra. A 5 minus P dot obviously 0. You delta I. But why it is important? Because from this concept, but here delta I is generalized thing. Okay. Now delta I is this. If you put this, we have actually got a term delta I. See here delta I by delta Q1, delta Q1, delta I by del Q2, delta Q2, and these all terms we can write as sum of J is equal to 1 to F del R by del Qj del Qj. F means number of degree of freedom 3n minus K. Okay. So what is if this is the delta Ri, because delta T at a particular instant of time when measuring the virtual displacement, so delta T will be 0 term. So now our expression, there are two terms. We are first simplifying the first term, Fi dot delta Ri. If delta Ri this much, then Fi delta Ri is equal to how much? Fi dot this, but taking sum over J outside because I sum is here is another I. So I can write like this. And this bracketed term is known as a generalized force Qj. Called generalized force. Generalized force is equal to sum of I is equal to Fi dot del Ri by del Qj. And one important thing is, as we already discussed, the generalized coordinate may be angle, may be momentum, anything. But similarly, generalized velocity, generalized force. But the product of generalized force and generalized coordinate always have the dimension of work. So product of Qj, delta Qj always have the dimension of work. Like other thing, force into displacement work. So here generalized force and generalized coordinate product is always have the dimension of work. Okay. Now simplify the second term. This is Pi dot del Ri. Using this del Ri, we can write Pi dot del Ri and slightly simplification. We get this expression, which is basically mathematical formulation. I can say this given already given in your material and slightly mathematical work. We got these terms. This is nothing but the Pi dot del Ri is equal to this derivative of a some term minus this, and this term bracketed term is equal to mi Ri dot del Ri by del Qj. Mi Ri dot derivative of del T by del Q. If T is the kinetic energy, you know del T by del Qj will be del by del R dot del R by del Qj, which will be this term mi Ri dot del Ri dot by del Qj. This term. So this will be d by dt of del T by del R del Qj minus mi Ri dot del R, this term del R by del Qj. This term is del T by del Qj and this one is del T by del Qj dot. So finally, we got an equation that this derivative d by dt of del T by del Qj dot minus del T by del Qj is equal to sum of Pi dot del Ri. Or putting this value here, in the first equation, Fi del I already know Qj del Qj. So Qj del Qj is equal to d by dt of del T by del Qj dot minus del T by del Qj. But our final conclusion, we got this Qj is equal to this. Qj, that means Qj minus this is equal to 0. And since it is sum over j, all j's are independent. Generalized coordinate. Generalized coordinate means they're independent coordinates. Since independent coordinates, we can say all j's. 1 satisfy this equation, 2 satisfy this equation, 3 satisfy this equation, and this equation known as Lagrange's equation. This equation d by dt del t by del q dot minus del t by del t is equal to qj. Okay. And this qj is your generalized force, but for a special case you consider for a conservative force. If qj is conservative, then using the definition of conservative force, force in negative gradient of potential, what is it? Fi is 1 minus del IV, negative gradient of potential. Putting this, we found qj is nothing but you put your in place of Fi minus del V minus del V by del qj. So right hand side of this equation becomes minus del V by del qj. Okay. So now take into the LHS side. So it will be plus. So there will be plus del V by del qj. So if you minus common, you find it, there is a minus T minus V. Again, it is a potential energy. The potential is independent of velocity term. So del V by del qj dot is equal to 0. So I can add here 0 here, or you can write del by del T of T minus V. And this T minus V is known as Lagrangian. Okay, we put like this. Since del T by del Q, del V by del Q is 0, we can add 0 here means T minus V. So this becomes 0, this T minus 1 is known Lagrangian, and this equation known as Lagrange's equation. Okay, but the Lagrange's equation and L is called Lagrangian. But Lagrangian is not unique. For a system, Lagrangian is not unique. Like your scalar vector potential for a definite electric and magnetic field, they are not unique because different set of scalar and vector potential give same electric and magnetic field. Similarly, here different Lagrangian also give same equation of motion. But all Lagrangian should satisfy this equation. The new Lagrangian must be old Lagrangian plus df by dt, where f is a function of qt only. If it is f cannot be q dot, it cannot be a Lagrangian which satisfy the same equation. Okay, this is all about same equation of motion. Okay, any doubt? Please ask questions. Hello? Am I audible?
This V is the velocity or the potential? Sir?
No, potential, capital V. Velocity we generally use small v.
Fine.
Energy, dimension of energy. So Lagrangian has the dimension of energy, kinetic energy minus potential energy.
Okay. And the potential energy is remaining constant. That's the reason the derivative is also 0.
No. Potential energy independent of velocity. That's why it is 0. It depends on function position only. Potential mgx or potential energy function of position only. In some cases, it may be velocity dependent potential. What we discuss in the next class, also in the syllabus, velocity. Some cases, electromagnetic potential or velocity dependent potential. Okay.
So the moment we are putting dqj, that is the velocity dot. Yeah. dqj dot, that is velocity. Okay, sir.
dqj dot.
Thank you.
Sir, what kind of questions are going to come in the exam?
Exams maybe if the long question derive Lagrange's equation from D'Alembert's principle, but in the slide, okay.
सर एक क्वेश्चन था
हेलो
सर एक क्वेश्चन था कि क्लासिकल मैकेनिक्स और इलेक्ट्रोस्टैटिक्स जो है हमारा उन दोनों का एग्जाम सेम डे और सेम टाइम पे रखा जा रहा है
ना वो मुझे पता नहीं वो आप उन्हें उन लोग से पूछिए ओके सेंटर से जो ऑफिस लोग हैं मुझे वो पता नहीं
सर सर हाउ कैन वी गेट दिस पीडीएफ फ्रॉम यू
ओके पीडीएफ मैं भेज सकता हूँ कैसे मेरा मेल मेरा मेल आईडी मुझे कांटेक्ट कर सकते हो या व्हाट्सएप नंबर पे कांटेक्ट कर सकते हो?
सर व्हाट्सएप नंबर में
हाँ, व्हाट्सएप नंबर है, मैं लिख रहा हूँ यहाँ पर 9777 969023.
Thank you, sir.
Okay.
Sir, this video will be uploaded in site, or this video only for classes? We can see only classes during classes.
वो मुझे पता नहीं है, वो ऑफिस स्टाफ से पूछिए, हमें ओनली इंस्ट्रक्शन है क्लास लेने के लिए. ओके, एनी अदर क्वेश्चंस और वी गो फॉर वन. हाँ बोलिए.
हमारे ग्रुप में सर आपको ऐड कर देंगे, आप काइंडली वहाँ पे पीडीएफ शेयर कर दीजिएगा.
ऐड कर दीजिए. मेरा पास है, मेरा ही है जो क्लासिकल मैकेनिक्स का ही है.
हाँ वही चाहिए सर. आपका जो कोर्स है वही शेयर कर दीजिएगा.
हाँ, मेरा पास में भेज दूंगा. ओके, मुझे ऐड कर दीजिए आपके ग्रुप में.
ठीक है
सर. द सेकेंड टर्म में तो डी क्यू डॉट तो नहीं है, सो लाइक लैग्रेंजियन जो टी माइनस नहीं. सो हाँ, नेक्स्ट वो 21 में the first d by dt dq dot है, so that is the velocity, but next term dq,
next term is generalized coordinate.
So then how the velocity, how the potential will be?
Potential comes from qj. Right hand side is our capital qj.
Okay, understood. Good sir.
Capital qj is equal minus del v del qj.
Fine, thank you sir.
Sir, one just questions. We are the first batch of MSc PH. Okay. Now we are at the fix that how we are going to attend this kind of questions, because there is no previous question papers, so we cannot judge what exactly.
I don't know about the question pattern. Okay, I don't know. You may ask.
You said one thing that derive Lagrange equation with the help of D'Alembert principle.
और generally asked in your examination in our university. Okay, generally this type of question will ask. So for that reason I tell that in our MS courses generally this type of question will ask, derive this. If long, I think if long question, if there will be other pattern, multiple choice or other thing, then will be questions will be different, problematic. I think there will be long question.
सर एक रिक्वेस्ट है सर एक रिक्वेस्ट है. सर हम लोग ईमेल कर रहे हैं कि एग्जाम का पैटर्न क्या होगा और उसका होगा, लेकिन ऐसा कुछ रेस्पॉन्स नहीं आ रहा है. तो क्या आप थोड़ा सेंटर से पूछ सकते हैं, क्योंकि आपको सेंटर से लगातार कॉल या मैसेज आता होगा, तो आप थोड़ा पूछ के बता सकते हैं उसका पैटर्न क्या हो सकता है?
वो लोग तो उनका गवर्निंग बॉडी वो डिसाइड करेंगे पैटर्न क्या है. वो आई थिंक दे हैव नॉट डिसाइडेड इट, फॉर दैट रीजन दे आर नॉट टेलिंग एनीथिंग.
Actually, the first batch in extreme difficulty. We are yet to get the books. Only some of the papers are PDFs are available. This is the first time by the virtue of Bhubaneswar is doing this program. That is good. Yeah. If it would have been 5-6 months earlier, then we could have grasped it better way. So that is anyway, that is our problem. You cannot. I understand you, sir. Thank you, sir.
सर इसका एप्लीकेशन में कुछ एग्जांपल ले सकते हैं क्या?
हाँ, एप्लीकेशन नेक्स्ट है, हम नेक्स्ट क्लास में अभी टाइम है तो एक दो ले जाएंगे.
एक्चुअली थ्योरी तो समझ आ रहा है सर, मगर उसका एप्लीकेशन कैसे होगा एक दो लेकर अगर हम समझाते तो बहुत अच्छा होगा.
लैग्रेंजियन एप्लीकेशन एवरीवेयर, इन फिजिक्स एवरी फील्ड, इन योर इलेक्ट्रोडायनामिक्स, इन योर हाई एनर्जी फिजिक्स, इन योर सॉलिड स्टेट फिजिक्स, everywhere every equation start from Lagrangian equation, because our aim is to get equation of motion, and we use Lagrangian formulation for getting equation of motion for every case. In every book you see this Lagrangian.
Hello sir. Sir, what type of questions may be made from this topic, sir? Please share a list of questions.
Okay, after the end of this course, I will tell you what type of question may be. Some long questions I will give you the probable questions of long questions.
The probable long questions, or maybe yes, if possible, short questions also.
Okay.
Sir.
Okay.
Thank you, sir.
Okay.
Sir, in exam, theoretical questions will be asked or problems will be asked just like assignments?
Both. I think both.
I
Because
think both.
uh, generally 60-40%, according to
Both
normal
will may
pattern.
come.
Hello?
Both type questions may come.
Uh,
If possible, so you please make a list of questions, problems, and theoretical questions, sir. And
Normally,
share.
questions which are asking in general MSc courses, I will give
Okay,
you that. Okay.
that's one, sir. Thank you.
Sir, how to send assignment paper?
Assignment?
Assignment paper. How to send? Where to send from West Bengal?
I don't know that. You have to contact the office staff.
Oh.
Okay.
Sir, can you move ahead of the other topics?
We go to next slide.
Yes, sir.
Hello?
Yes, sir. For next slide, which topic you will teach, sir?
Next slide will some applications of Lagrange equation.
Sir.
Then we go for Hamiltonian. Okay, what in the,
Okay.
then go for central force motion. Okay. I think you have a class at 5.
Sir, for that one.
Hello?
Hello, sir. For next slide, sir, please share this notes, sir, for Hamiltonian or the whatsoever, sir, in
No.
group.
After end of my classes, I will send the material to you. Okay? And then after every class.
Sir.
Okay.
Then no problem.
Sir, sir, I am talking for next slide, sir. Next slide note, sir.
Next.
Next slide note, if possible, you previously you sent, sir.
No. I am also first time sir invited me to give this. Okay.
ओके
सर वो बोल रहे हैं कि नेक्स्ट जो क्लास होगा उसका जो आप नोट्स जो पढ़ाएंगे वो पहले से भेज दीजिएगा ताकि हमें वो पढ़ के आ जाएंगे, हमें पढ़ने में आसानी होगा आपसे।
सर
Absolutely, sir. I sir.
तो
That
क्लास
is a
में
great thing, sir.
क्लास में ज्वाइन नहीं करोगे तो पहले से नोट मिल गया।
नहीं सर ऐसा
नहीं सर
become very
एक्चुअली
difficult.
ये अच्छा रहेगा हम लोगों के लिए थोड़ा आइडिया भी मिल जाएगा।
Other thing is all notes are not prepared by me. I am taking time to prepare the notes.
नहीं
First
at
time
least
learning,
अगर
okay.
टॉपिक क्या रहेगा वो भी अगर बोल देते हैं तो भी वो हम लोग कोशिश करेंगे।
हैमिल्टोनियन सेंट्रल फोर्स मोशन ये मुझे बोल रहे हैं तो मैं
ये
वो
नेक्स्ट डे के लिए
सर
अभी
एक
मैं
घंटे
prepare कर रहा हूँ उसका नोट। ओके
सर 1.5-2 घंटे पहले अगर भेज देते तो थोड़ा हम भी कोशिश करते कि थोड़ा ज्यादा समझ पाएंगे सर।
हाँ
ओके मैं ट्राई करूंगा ओके
सर
मैम ये सर सही रहेगा कि आपको जिस ग्रुप में हम ऐड करेंगे आप वहाँ जो आज का पीडीएफ भेज देंगे और कल के लिए जो होगा आप वहाँ पे लिख दीजिए कि हाँ कल ये पढ़ाएंगे।
लिख दूंगा।
थैंक यू सर।
ओके
सर हमारे बुक में 2 इक्वेशन है। हमारे बुक में एक तो है लाग्रांजियन इक्वेशन ऑफ मोशन ऑफ सेकंड काइंड और एक तो है लाग्रांजियन ऑफ डायनामिक सिस्टम। जो डायनामिक सिस्टम को अप्लाई करके अभी जो आपने जो कराया वही है एलर लाग्रांज इक्वेशन ऑफ मोशन और जो पहला वाला जो है लाग्रांज इक्वेशन ऑफ मोशन ऑफ सेकंड काइंड वो काफी मिलता जुलता है मगर वो खाली टी को लेकर किया है। वो एक्चुअली इसके साथ कैसे रिलेटेड है?
कौन सा लाग्रांज इक्वेशन?
जी है डी बाई डी टी ऑफ डेल टी बाई डेल क्यू आई डॉट माइनस डेल टी बाई डेल क्यू आई इज इक्वल टू क्यू आई।
सेम है तो हम तो अभी सीखे
और
ना क्या पर लिखा
जी
हुआ
जी
था
अगर जी हमारे जो इग्नो बुक में है ना वो 2 दिया है। ये दिया है और लास्ट वाला इसको लिया है एलर्स
प्रीवियस वाला था ये डेल टी बाई डेल
सेम ही है ना। उसमें खाली टी को लेके दिया है। इसमें
ये तो है
पूरा
इक्वेशन 18
दोनों सेम है या जी जी जी
दोनों सेम वहां से वहां डिराइव हुआ ओनली v आर qj इज फॉर कंजर्वेटिव नो सेम मींस इट इज फॉर
जी, जी।
ऑल सिस्टम्स दिस Lagrangian L is for only conservative system For conservative system, we can put capital Qj is equal to minus del V by del Qj. For conservative,
थैंक यू सर
okay.
जी समझ गया क्यू में क्यूआई में वो खाली नेगेटिव ग्रेडियंट होगा वो
हाँ, for conservative
जी
system.
अच्छा ठीक थैंक यू सर
ओके, तुम्हारा नेक्स्ट क्लास है, मैं क्विट कर रहा हूँ. थैंक यू ऑल. ओके.
Thank you, sir.
Thank you, sir.
Thank you very much.
Thank you very much,
Thank
sir.
you, sir.
थैंक यू सर
Thank you, sir.
Okay,
Okay.
sir.
Thank you, sir.
Okay, sir. We'll be looking forward for next class in Hamilton equations and applications.
Thank you, sir.
Okay.
Thank you, sir.
Thank you.
एक रिक्वेस्ट था, अगर किसी के पास हैंड रिटन नोट्स हैं, मतलब अभी